Hello and welcome to episode 2 of Super Simple Scala. Today we are going to talk about things that tend to be snare points when you're just getting started. The first thing is containers. So you're used to your Java containers, val array equals new java.util.ArrayList. Let's say it's an array list of int, array, whatever. This is an array list. Array list dot add 5. Right, so this is what you're used to. When you first get started with Scala, you might have something like val list equals list 1, 2, 3. Val list 2 equals list left. Let's make these equivalent. List left concatenate. So you'll see all the methods are in here. The concatenation is attached from that side, from the side of the colon. So if we wanted to do left concatenate, it would be like that. And right concatenate would be like 5 plus colon list. So in Java, it's pretty intuitive and easy because all of your methods are in English and all of the documentations are working, right? So you can just look at these and you go, oh, add, remove, whatever. With Scala, you oftentimes run into methods that are symbols, like plus, colon, plus, plus, plus. The way the syntactic sugar works is, let's say you have dot plus colon 5, val list 2, 2. So these two are the same. This, with the colon and the parentheses, desugars into that. So that's one thing that beginners get confused about. The other thing is, how do I figure out what these symbols mean? Oftentimes, just read the Java doc. Very long, very scary looking. You've got very scary looking type signatures up there. But yeah, start by reading the Java doc. If the Java doc fails for any reason, for example, if it doesn't appear, you could always check the website. No documentation found or something like that. Your most commonly used methods are going to be plus colon and colon plus. So plus colon and colon plus. If you bring up the REPL, so for example, in the REPL, if we did val list equals list 1, 2, 3, and then if we did list colon plus 4, the colon goes on the side of the container. So now the 4 is on this side. And if we wanted the colon it to be on the other side, we could do 0 plus colon list 0, 1, 2, 3. The colon is actually, it basically tells the compiler to make it right associative. This thing that we did over here is actually equivalent to list dot plus colon 0. Incredibly boring, I know. But yeah, there's a lot of syntactic sugar, but these two are the same. With your containers, of course, if you want your Java containers, you would just do, java.util. And then pick whichever Java container you want. You've got all of your Java containers. When you just start out, it's very tempting to use Java containers because that's what most people know from programming 1, right? But then what will end up happening is you'll start using the immutable containers. So scala.collection.immutable. Let me move down here for a second. You'll start using the immutable containers. I don't know why it says cannot find macro. I'm sorry. I wish that worked. But you'll start using immutable containers like mutable list. Map is pretty common, which is hash map. Set is like a list, but there's no repeats. You check to see if something's in the set. Stack is what you push and pop. Remember programming algorithms 101. Vector is like your immutable array list. It's kind of like a substitute for array list. But yeah, these are what you're going to do for most of your operations. For most of your containers are going to be these: Scala collection, immutable. Okay, so those are your containers. Oh, and of course this, and if you have two different lists, val combined equals list plus plus list2. This will return a new collection containing the elements from the left and the right. So if we had like list plus plus list 4, 5, you would get 1, 2, 3, 4, 5. This is very confusing, but let's just say you had val list 4 equals list 1, 2. That's going to be the same as val list 4, 4 equals, let's see, 1, 2, nil, I believe. We can check that later, which is going to be the same as val list, let's see, 4, 4, 4 equals nil dot colon 2 dot colon 1, I believe. Not 100% sure. Let me see. Let's leave that one for later. I know that the colons usually translate into dot something. So if we had this, list 1, 2, oops, val list 4 was 1, 2, val list 4, 4, is that, and let's just say we had 2 nil, that would be just a list with 2. But if we had nil dot colon 2, that's the exact same thing. Now let's say that we had nil dot colon 2, and then this is why things confuse me. Sometimes when I get confused by syntactic sugar and I want to get rid of the syntactic sugar, I use my library, Scala trace debug. In addition to having functionality, let me make myself visible. Get rid of, minimize, there we go. In addition to having functionality to help you sort of locate all of your, it gives you like sort of clickable line numbers, positions for your log statements so that you can kind of navigate to them quickly. But in addition to having that, it has a feature for removing syntactic sugar, which is really convenient when you're confused by syntactic sugar, which when you get started happens. So let's go build.sbt. Added my library. That'll take a second to be added. But yeah, one feature that's in my library is container printing. Syntactic sugar removal, right? So if you have trace expression, expression 1 plus expression 2, it turns it into expression 1 dot plus expression 2. So foo plus bar, string foo plus string bar makes string foo bar. So we're going to use that here. We're going to do import info dot, no, import scala dot trace dot sdebug, Scala specific debug methods. There's also, so there's sdebug, which is Scala only. This feature is Scala only. There's debug, which is both Scala and Java. There's pause, which just gives you a position. Don't worry about compat. There's pause, there's log, which is used with log statements. But we're going to use sdebug. And sdebug has a method called trace expression, which we're going to use to trace the expression 1 : 2 : nil. So yeah, everything, I'll explain how expressions work later, but let's say we wanted to trace 1 : 2 : nil. And if we run this, hope this works, fingers crossed. If we run this, I need to separate print ln. Let's add some white space. New line. Run main. Sorry, I'm boring you, but oh my god. Okay, so that's what it converts to. Eek. Yeah, so the syntactic sugar can be quite frightening sometimes. I think the reason for that is val list 5 equals 1 : 2. So you can do 1 : nil, and then you can do that : 2, and that I suppose should translate into terminal. That's list 1, 2. And then nil dot : 1. See, even I get confused by syntactic sugar. And then dot : 2. There we go. That's what it turns into. So this, there we go. Val list 444 equals that. So this, and this are all equivalent, these 3 lines. Very confusing. Okay, let's go through some other stuff that confuses beginners. So we got through basic. Oh, I don't have time to tell you everything about data structures, but we just went through type signatures. You saw how scary some of the type signatures were. So if I were to just get rid of that, pull up something like list dot, and then just drag this way over, move to the corner, list dot way the hell over, right? So now we're all the way over here. And we're looking at this. These are some scary type signatures. You know, what's can build from? What's an implicit, right? When you first start out, you're gonna be using your arrays and your lists, and you're gonna see these type signatures, and you're gonna go, what on earth is can build from? Where will I ever use it or see it? You know, what's an implicit? You know, and you're gonna see this, and it's pretty frightening the first time you look at this. But eventually you end up using these traits, and eventually you'll start to understand, oh, I understand what this means. You know, this means that B is not a subclass, a superclass of int, you know, right? So you're going to look at, what's the partial function? And at the very first, when you start looking at these type signatures, it's going to be very scary. But when you start out, start by reading the Java docs and the example code, and then worry about understanding the type signatures after you sort of get a more stronger understanding of the language, right? But yeah, this is why it's not your first programming language. Java compatibility. For the most part, Scala methods and Java methods can call one another. You start running into issues with when you use names that would be illegal in one language but not the other. There's this thing called name angling, but in general, if you want to write code that can be called from Java, it's usually preferable to use names that are legal in Java. For example, you can write a function in Scala called like def func, question mark, like you can call a variable called like val my variable is true, question mark equals false. And this is a perfectly legal name. It will compile. But if you have like a method called like def is true that returns true, and it's and it's got a question mark. I can't spell. And it's got a question mark, then that will compile, but you're going to have trouble calling it from Java code. So there's that. Oh, also conversions between sort of Java containers and Scala containers. Scala has mutable containers like Java containers. Scala.collection. So most of the time in Scala you will be using immutable containers. But with Java uses mutable containers. So there's going to be things like, array buffer, things that sound really similar to the names of Java classes. And Scala actually has conversions for those. So Scala convert a Java container to Scala container, right? Scala implicit convert Java container. No. One second. So if I were to go to container, there it is. Container printing works for any container to pass in Java containers, import Scala collection, Java conversions. There we go. So these Java conversions will convert something like a map, a mutable map to a Java util map, mutable buffer to a Java util list, etc., etc. You're not going to learn implicit conversions until later. One thing that's really scary about Scala is it kind of throws all of these advanced language features at you. Like you start to see them right away when you're just starting, and you're trying to, and at the beginning you're worried about like basic data structure stuff, and you've just got all these advanced features going on. But yeah. Let's see. So yeah, you've got names. Whenever you're confused by a name, just Control Q it. Control Q, and then you'll see, your description. Sorry, there's a lot of confusing stuff. Let's just get it all out of the way, and then you can focus on actual content. So we got rid of that. Confusing type signatures. Covariance versus contravariance. I always get these confused. Function, covariance. Covariance is what goes inside. Like I said, I can't spell. But basically your covariance is what goes inside of your function, right? It goes down the type hierarchy. Don't worry about that until later. Adapter pattern, you'll see it in like object-oriented programming. There's something called an implicit conversion for that. Don't worry about that now. There's a lot of syntactic sugar. Some of it, if you try to sort of de-sugar it, looks really frightening. The way expressions work in Scala is basically, so an expression, so for example, if you had something like, val my expression of type, string is equal to, val s1 equals hello, val s2 equals world, val s3 equals s1 plus s2. Okay, so so this is like a block of code, and it will return the last thing in the block. That's how methods work. If you look at the way methods are defined, def, method equals, well, methods are usually, don't worry about the function closure, let's call this a closure. Def closure equals, returns a string, equals like this. So the idea behind the way the equal sign is being used, it's supposed to represent like a function is like a value. So here you have the notion that, this function is like a value. Here you have a notion that this expression, the entire expression is like a value. There's this concept called referential transparency where you can substitute one thing into another thing and you get the same thing back. That's kind of an important concept, right? So, but yeah, referential transparency expression, I'll say it's like roughly equal to expression substitution. If you can substitute this everywhere where you get this and everything's the same, it's referentially transparent. Okay, so we covered referential transparency, syntactic sugar, domain-specific languages. If you've ever seen something like Scala test, unit tests, Scala tests. So for example, like a stack should pop values in last and first out order. This is a domain-specific language. It's meant to look like English. Domain-specific languages can produce very scary type signatures. Oftentimes you shouldn't be reasoning about a domain-specific language. I mean, I personally don't reason about domain-specific languages the same way I would reason about like application code. I just think of it as sort of syntactic sugar that's supposed to look like a language. So for example, if you were to take this, I don't know, I have a Scala test, recent projects. I'm going to pull up this project that I did. Projects, experimental. Okay, right, so container. Okay, container printing should work for arrays, lists, maps. Okay, so if you look at should, and you look at the type signature, there's a write, there's some implicit something, result of string pass to verb, result of string pass to verb. Oftentimes you can get kind of confused by, if you look at, I don't know, in, for example, sometimes if you focus too much on like the type signatures and sort of how everything fits in a domain-specific language, you can get confused easily. With domain-specific languages, the way I sort of remember them is I just sort of remember them as sort of like, a language. Like this, don't think of this as, even though this is code, I don't think of this as code. I think of this as like English almost, right? I don't go, oh, wow, what a crazy type signature. Let me figure out what the super type is and substitute that in, right? You're just looking at domain-specific languages as a language, not as logic. So we covered domain-specific languages. Type aliases. Sometimes if you have a very frightening type, simple type equals int, my val of type, this should be uppercase, simple type equals 5. Okay, so you can use type aliases to replace very, very long, scary type signatures. You'll see long, scary type signatures every now and then. try not to write too many yourself. So Syntactic Sugar. Programming without mutable state gotchas. So when you first start out, you end up programming with like lots of mutable state because that's sort of how you learned from like C and Python or whatever. And then you a lot of times they'll learn Haskell and they'll go, oh, no mutable state at all. We want no mutable state, and so they'll use recursion everywhere, and they'll never stop using inheritance, and they'll make all their functions as values that are final. And but Scala gives you sort of two ways to do things, and you have to think. I mean, once you actually like learn the language, you're not thinking like only do it this way or only do it that way. You're thinking which way best makes the most sense for this problem in this location. Generic programming. Generic programming can be confusing. A lot of things that are very straightforward and easy to sort of think about when they're concrete become a little bit harder to think about when they're generic. At least people who are looking at it for the first time. Usually you want, like especially if you're going to, let's say you're implementing something, you want to, at least I personally start, concrete and then make it generic. So we can give you like an example of like a monad. You'll learn what that is later, but like you can implement it concrete, like a concrete like int monad, which only works for one particular type, or you can make it generic and make it work for a lot of different types. But yeah, generic programming. Existentials. There's a lot of different uses for underscore in Scala. I'm going to cover them really fast. An existential type is a type where like we don't know what it is, so just pick whatever it could be, pick some type that it could be, given that we don't know what the type is. So for example, if you had like Scala Java existential type, so if you look at, I don't know, look at this example, this bottom one. This is, if you were to, in Scala, this would be an underscore. But basically, the way I read it, it's sort of in my head, is I think there's a list where we don't know the type, and we have to sort of make a safe guess about what the type is. So if we don't know what the type is and there's no bounds on it, we can't. We have to pick the broadest guess possible when calling the add function. So list don't know. We don't know what the type is. It could be a string. It could be an int. By calling xs.add84, the way I think of it is you're saying add an int to a list where we don't know what the type in there would be. So if you don't know what it could be, what it is, and there's no bounds on it, and you're trying to put in an int, and you might be putting in an int to something that has strings in it, and they would pull out strings. So that's not safe. So the compiler won't allow that. But yeah, generics, existentials, higher kind of types. K underscore, this is a type constructor. What it's saying is that if you think of like there's like a list of int. Let's say there's a list of int, and then there's just a list of insert list of insert type here. if we just created a list of insert type here where you can put in a type in that place and it becomes a concrete type, that's a type constructor. So this K could be like list, right, or array or something. And we're saying a list of insert a type here, and then once a type is inserted, it becomes a concrete type. So here we have a list of insert type here, and we have a type, and then we have a value, which is that type applied to insert type here. So a type constructor, K, plus a concrete type makes a concrete type. Geez. Ignored variables. I've never had to write underscore equals 5 before. Underscore usually is used for like don't care. So if you have like a function that you're only using 2 of the 3 parameters, you can indicate that you're not using the third parameter by putting an underscore in there. Like this. So we're saying don't care. So in the first here, this means I interpret this as don't know. In this case, I read this out loud as insert type here. Here, I read it as this underscore means there's a parameter that goes in, but we don't care what it is. So here it means don't care. Here it means some blank or something. Here it means any, import java.util, no, all, import java.util.all. When I read code, I often think out loud in my head, and sort of this is how I think of it. Hiding imports. I don't use this too often. Array list. Joining letters to punctuation. So if you want to do exclamation point or underscore, exclamation point is used to indicate side effects. You could also use a name that's indicated with a side effect, like a name like, turn switch on. The word on indicates side effect. Assignment. This is sort of, this and this are sort of similar. This underscore is pretty much the same as an ignored parameter. We're saying, no, this doesn't mean don't care. This means, the given. So for each of the given things, print ln 5. For the given thing, add 2. For each, print ln the given thing. Jesus Christ, there's, let's see, for each process something. There's a lot of different uses for underscores, and they mean slightly different things that are sort of kind of related. Getting my head to kind of understand and remember and differentiate them took a little while. Oh my god. Partial functions, don't worry about that now. Recursions, so sometimes when I would have a habit of I would write a recursive function about recursive, equals, let's say it takes in I and int, and it returns, this will loop forever, returns recursive I plus 1. And then let's make this sensible. So if, I is equal to 0, return 0, else we'll do recursive I plus 1. And now you might think that, I can take recursive and I can put in, -5, but it'll say, it will kind of give you problems, right? So what ends up happening is, what I end up having to do is, this is going to be something that takes in an int, and returns an int, and now it works, right? So if you have like a recursive value, you have to include the type specific more like concretely. Ooh, there's a lot of confusing stuff. I'm just trying to blast through it. Equal sign on methods, thunks. Basically, if you have a method that takes in def take in boolean, returns something, let's see, something that, let's see, I returns a boolean, and let's say it returns, takes in I, not I. Okay, so all that this symbol means is that it takes in something that, there we go. This takes in something that returns a boolean, an expression that returns a boolean, but we don't care if that expression is like a block of code, like this closure over here. This isn't a closure, sorry. This is, let's call this a, I don't know, exp. It doesn't really matter what we call it, x. This block of code over here, let's call it, str string block. So this is a block of code. So we don't care if we're passing in a block of code that returns a boolean, or if we're passing in, a function that returns a boolean, or we're just passing in something that's going to return a boolean, something that you can think of it as a boolean, right? This kind of helps the people who are writing libraries make them more like broad, make them work with both values and functions. Thunks, keywords. We covered all the different uses for underscore. Existentials. Don't know. No, literally, we don't know what the type is, but we can put like we can put bounds on it. We'll worry about these later. Compiler flags and compiler checks. Very important. If you look at something like so much crap, build.sbt. Alright, so if you go down to, compiler, Scala options, you've got, a bunch of different options. In general, the more sort of checks your code can pass, the better. Oftentimes, these options will catch things that were mistakes or that were bad and that you didn't realize they were bad. Also for style, I use Scala style. Scala style prevents you from making terrible style decisions. Your most used Scala options, feature warnings, linter. When you're first starting out, you're going to want to Scala, let's see, compile option, warnings to errors. You're going to want to be treating warnings as errors initially, -x fatal warnings. What that does is it turns all of your compiler warnings to errors. This stops you from writing shitty code, because when you start out, you're going to write really shitty code. I still write pretty shitty code. Let's see. type inference has limited scope. So for example, if you have something that takes in, if you have a function that where you can do some sort of type inference, so list dot map don't care times 2. All right, so if you look at the underscore here, now people sort of intuitively reason about things that are referentially transparent better than they reason about things that aren't. So if this is referentially transparent, you could just say val my val equals that, and then substitute in my val. That doesn't work because the type inference, it's not smart enough to take this and put it in the place it was used. It's not smart enough to say, there's only one place this is used, put it in that place, and then do type inference. This type inference is local to within these parentheses. And this is the same as if you were to do, int int to int times 2, right? Or if you want to be overly verbose, int of type int to int times 2. I'm not going to do that. That looks ugly. I prefer this because at least this you're being explicit about what the thing is inside of the. At least you're being specific, saying like, here's what's inside that we're performing the mapping on, instead of saying like, oh, we don't know the type and we're doing some operation and we don't care. So flat map filter, blah, 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 compile checks, nested closures. Oh, so if you have nested closures, let's say we had map and then dot map. Let's say that we're going to keep mapping. Should we keep mapping? Dot map. Don't care times 3. And then let's say that we did maybe one more map, but this time we're going to map each element to a list of elements. So we're going to turn each int and we're going to do a list with that 0 and that int. And because we're making a list, let's flat map. There we go. You want to line up the periods like that. That makes it look a heck of a lot better. 1 second. So this is a bunch of ints. This is a bunch of ints. Holy shit. You're going to use these a lot. One second. So let's say you have flat map I to, I don't know, a list of I. There we go. But yeah, these line up. If you have nesting, so for example, if you had int and then you had don't worry too much. Parens, no parens. Oh yeah. So side effects, side effects, side effects. This means side effects. if there's an exclamation point or a question mark, you have to create a space. That's just a weird grammar glitch. Also, this also means side effects. If you had, if it didn't have any parameters and you had parentheses, that would mean side effects. Like this, that would mean side effects. No params, or that. You can also indicate side effects by the way the name is written. So if the name was like, turn switch on, right? This name is a command, turn switch on. So the name, so sort of command implies side effects, whereas if the name of a function was just like myString, if it was just a noun like that, that would indicate that there's no side effects. There's a couple different ways you can do it. Pick whichever one looks best, or that your team is using. Indicate side effects. Data structures, there's a lot more about data structures. The hierarchy is a little bit confusing, but yeah, those are the things that would confuse beginners.